please ask questions. Let's not pass this stuff, because you know what's going to happen? You're going to go back to your bay and you're going to say, God, I had a question, I should ask it. I have been in the audience. I have wanted to ask questions and I have been too afraid. There's no stupid question, guys. There's a question that needs to be answered so you can utilize this technology in your bay on Monday. Yes, sir?
The difference between the percentages you fuel trim, is it possible for that to not equal that 130?
Absolutely. His question, a very good question. Is it possible that the fuel trims will not equate to the air reading? Absolutely. What happens if we have a bad fuel filter, guys? And it's on that side. The mass air read absolutely right, didn't it? But I didn't get the fuel into the motor, so it had to turn the injector on longer because I dropped fuel pressure. Is that correct? That's why we use the table. And believe me, if I can get here today, I'm going to show you how it works with fuel pressure and how an exhaust affects this. What I'm talking about isn't for mass air. This is the whole system. This is the cam phasers not working. This is a plugged exhaust. This is a fuel pump or a line that's smashed. This is whatever you got a problem with today on your car, you can figure out with 2 tables. It is pure magic. When you get this, you're not going to believe you ever fixed a car without it. That's what I'm going to tell you. And I make a statement. How many people in here do this technique? Please raise your hands. Am I lying? Is this pure magic? Someone, is this magic? Is this magic?
It works.
It's hard to believe how good it works, guys. You got to just get through this idealistic thing that you've been looking at these numbers on a scan tool that don't represent what you need to be looking at. What we're doing is the numbers that you need to be looking at. You know that this drivability tool that we make, it's generic. It works on every car. It's generic. Why would it work on generic? Because the engineer that engineered that car gave you every piece of data in generic to fix the car. We just don't know how to utilize it. I'm here to show you how you're going to utilize it. I am here to help you guys. You've got to understand. I am a mechanic like you guys. I'm no different. I owned a shop for 29 years. I got my teeth knocked down my throat every day. I had cars in my bay. I didn't even want to go to work because it was there. It was there for 3 weeks. And that black car's still there. And you know, there's nobody else that's going to fix it other than me. It's tough. But what I'm going to tell you is we make it hard. Honest to God, we make this stuff way harder. I am responsible for making it harder on myself. Back in the 80s, I didn't have the understanding. Every bit of knowledge is gained for you to do better. I've come to share some knowledge that took me 35 years to understand this. I had such a problem. I started a tool company because Snap-on and Mac and these guys don't understand it. They're an engineering firm that all they're worried about is getting you some scan data. That isn't what I need. I'm not saying that I don't use it, but I need another level. I need something I can fix cars with fast and accurate. I mean, I had a very successful shop. I had 8 techs, 10 bays, 30 years under my belt. I stopped doing that so I could come and help you guys because I know where you are. I'm telling you this because I am you. I'm not some engineer. I'm a mechanic. And I had to come to do this because I couldn't stand not fixing cars and losing all my profit. I wasted all my profit on 5% of my cars. And if I don't fix those, I don't get the timing belts, I don't get the brakes, I don't get the oil, I lose my shop. You guys got to start to do this. You got to start to use scopes. You got to be more intelligent than the guy down the street. We got to fix cars better, faster, more accurately. I'm here to help you do that. We have a 2000 Chevy Silverado. This is the car. I have low power, DTC's low O2 voltage, good MAF sensor. He's put one on. He knows it. It's used, but it's good, guys. He's got all the new injectors, and he's put all the oxygen sensors in it. Here's my car. I have O2 failures. Pending codes, notice. I haven't driven it long enough because he's cleared the codes. Anytime you have not run the monitors, always pay attention to the monitors. If the monitors haven't been run, you're not going to set hard codes, right? You need to set you need driving time to set the monitors, or enough time to overcome the monitors to set a DTC. We're not going to get involved in the monitors, but that's an idea. Always pay attention. Did the monitors run or not? O2, 1, 2, 1, 2. Okay, all the O2s say it's lean. Do you think it was a good idea to put 4 O2s in because they're all lean? They're not all bad, right? But this is what we do because we don't understand. Let's try to understand this stuff. Why do I explain this in such depth? Because that's how you fix stuff. When I understand how it works, I can fix it. When all these engineers tell me half-truths, I have a real problem. I have read so many white papers from the engineering companies, I can't even tell you. I spend thousands and thousands of dollars every year in papers. Any new system, I go in and I read at least 100 to 200 papers on the system, because I have to know how it works to fix it. I'm trying to help you guys with all the patents that I've read and all the SAE papers that I've read. That's where I got all this information. It's there for you too. Join SAE. There's all kinds of papers. There's books. If you want to do this, that's one way. But all of you are doing great because we're out training. The O2s probably are not the problem. Okay, so what size engine is this? Is 4.2 going to cut it? I don't think so. This is a Chevy. This ain't a Kia. This car should have 4.4. Usually you're above your target. So if I have a 5-liter, 5.2, 5.3, sort of what I expect. These are all rules of thumb, but it's stuff I expect. Does that make sense? It's what do you expect? Have targets. Have rules of thumb. I live and die by those rules. I have rules of thumb. I see it. It's not right. I go look at it. It doesn't mean that it was wrong, but it sure means that I need more attention spent when I see something break a barrier. Does that make sense? I do lots of rules of thumb. And I stand up here like this is all definite stuff. Like this is the rule, this is the rule. Dude, there is no rule. The only rule is everything changes. But if I don't start some kind of a definite point to where I can say I need to look at this now, how can I fix the car? I'm doing just what they do when they program the car. They make a threshold that breaks the threshold, I set a DTC. Does that make sense? I'm doing the same thing, working on it. I set these rules up and these boundaries, and when things don't make it, I go look at it. This rule is I should have equal or more air. How would I know I've got a problem right now? If this is the wrong air rate, 4.2, wouldn't I trim for it? Okay, I've got 11%. That's not horrible, right? Up to 10 I don't even worry about. So I'm really close, but a little bit off. And aren't we just a little off from 4.22 to 4.3? It's not that much. But I am trimming. Always look at your trims and look at your air rate. If the trims are right, what do you know the air rate is? It's right. If you don't trim it idle and this number's not right, what do you know? It read the air right, because if it didn't, it would trim for it, right? That's the idea. Has to trim if it's wrong. Here's my used math. 23 to 36 gets worse, right? It's all red. We know it's broken. So I know that my trims aren't right. If I come down here, I've got 29 to 40. Those are pretty close, right? Trims, when you do this game and you're comparing the trims to the VE, aren't your trims with perfect motor, aren't they +8, +4, -3? Don't I have some variant? So if I was looking at the numbers and I have a little bit of variant, wouldn't that be normal? They're not going to be exact, close. Close, because trims, I'm already trimming for something. That's why when you look at perfect trims, they're +3, 5, 6, 2, 1. So I've got to take that into account, that these could be a little off. I'm close, right? So if the VE misread and the trims follow the air, what do you know? The mass air is bad. This is this guy's perfectly good mass air that he puts on all his cars to check them with. Okay, so one thing I want to do first is we always proof circuits. I don't care what system you work on. It's a tranny, it's HVAC, it's ABS, it's transmission control. We always check powers and grounds before we put parts on, right? Always. How do you do it? A scope, because you cannot see the stuff with a meter. If something very fast happens, meters average. Most meters, 100 millisecond average. That means 100 milliseconds in electronics is eternity. We're dealing with a couple of milliseconds, not 100. Do you understand that? Meters don't work. You need to start using a scope if you really want to become proficient and fix cars. I'm going to go in and I'm going to plug these. I had a gentleman ask me earlier, how do I know what wire to get in? Do I care? Guys, I'm a flat rate guy. I don't got time to go look up every wiring diagram. I put a scope on it. I know, I drove around the block, the mass air is bad. Why do I know that? The VE and the fuel trim are telling me that that's what's wrong. Do you understand that? The mass is what's bad. He put a mass on here. I want to make sure that he's not putting a mass on and it's this perfectly good one and it really is, and I've got a bad power of ground, right? If I have 3 wires, what do I know I have? 12 volts, ground, and a signal. If I've got 5 wires, I got 12 volts of ground, a signal, 5 volts, and a temperature sensor. Does that make sense? Do I need a wiring diagram? I don't need a wiring diagram until it's not there. Do I know the signal's being produced? I do, because the scan tool gave me a reading. If there's nothing there, I need a wiring diagram to make sure they didn't switch the wires around in A and B, right? I got to be more careful. I got to slow down. Use your intelligence. You guys are smart. Use it. You can do it. I'm not going to do that. I'm going to plug in all the wires, and when I bring up my, what do I know I'm going to have? I'm going to have 12 volts of ground, I'm going to have a signal for my air temperature, and I'm going to have a signal for the mass air. So, GM does not use a voltage as we've seen so far where it's an analog signal. Mitsubishi and GM both do digital output, which means that I take a reading from the MAF sensor, and inside the MAF sensor, I'm going to have a frequency generator. So it's going to change voltage to frequency. So now GM, in their processor, uses a very accurate clock, and I clock each stroke rise time. So these rise times, from this guy to this guy, I'm timing those, and I can figure out the hertz. GM's hertz is going to be 0 to 12,000 hertz. Somewhere in between that is depending on what car. But that is the range of a GM sensor. So if I've got 5 volts, and do you see how this is being pulled down? The 5 volts is being supplied from the PCM to the sensor. You understand that it's really important to know what sensor, whether it's a crank sensor, cam sensor, does that sensor produce the voltage and send it out, or does it take the voltage and modify it? This sensor modifies it. It takes a 5-volt signal and it modifies it by pulling it to ground and releasing it. Now this gives me a frequency base that I can count the frequency, and I go to a transfer function table. Rather than looking up a voltage that equals grams weight of air, I have frequency equals gram weight of air. Does that make sense to everyone? We're doing the same thing, we're just doing it a little differently. It's just a different flavor. Okay, do I have 12 volts? Do I got grounds? And do I got a temperature sensor that's somewhere between 1 and 2? I'm okay with that right now, right? And do I have a frequency, and am I pulling it down? Okay, so here I snap the throttle because I want to make sure it's not losing signals when I snap it. I'm going to load it, right? Always dynamically load everything. If you can load it, load it. You want to check it where it's easy and where it's hard for the sensor to produce. It's much harder under a high air rate to produce it. This is my sensor. Don't I want to make sure that these aren't dirty? These are a different type of sensor. We looked at the other sensor from Bosch that has a real thin wire, 2.7 thousandths, and it's platinum. This is an alumina ceramic material that is also used by Toyota, Lexus, and Ford. It's the same type of a sensor. They take an aluminum wire, a titanium wire, and they wind titanium, and then they cover it in a covering. And that covering can get dirty. Where does the dirt come from? A couple of things. The air filter itself, if you get cheap air filters, they don't put a paraffin base on the filter, so the filter elements will come off and get stuck to it. So you need to buy good filters. If you don't seal the induction system good and the lid is not properly seated, you know how when you race and you go around the racetrack and you get all the slag they talk and it's rubber chunks out there? Where does all the rubber come from? The tires? Like when we put Abe's head in it and it doesn't hit Abe's head? Doesn't that come off? That's very fine rubber that's in the roadway. And when your car goes through it, it gets aerated. And that rubber will get pulled in if you don't have a good filter, and it gets stuck to that wire because that wire is how hot? 425 degrees Fahrenheit. It melts to it, which makes it harder to clean. It also gets PCV and debris from the crankcase ventilation systems and EGR systems from reverberating air coming back up into the sensor. That's why a lot of these are moved way off. Remember how they used to put them right on the throttle? Well, that's a problem because they get dirtier. So notice what they did? Aren't they all way away from the engine? So it doesn't carry that debris and get it as dirty. So they do different things to try to correct it. Notice the temperature sensor is always located close. These are clean, so the sensor's just bad. I told the guy, where's the original sensor? Not your known good one. I want an original one. And notice what his known good one is, 2000 Yukon. That's a really nice one, huh? So we're going to put the original one back on. Now we've got 23, 22 going to 42. We've got 22 going to 27, 20. Now the problem with these trims is I just swapped the sensor and drove it right down the street and came right back. I didn't give it time to correct the trims, right? If I want to correct trims, what do I got to do? I got to drive the car long enough in each cell for it to be able to trim that cell, or I'm not going to trim it. If the engine isn't dynamically working in the cell, no trim occurs in that cell. It's just part of the program. This is the original MAF. Okay, this MAF is better than his known good one, right? That's his known good one. Here's his original one. It's better than his good one. He put a junkier one on there. No, we laughed because he used a used sensor. But guys, I just went out to a shop a few months ago. The guy had 2 brand new Bosch Mass Airs on a BMW, brand new. Got it from WorldPack, great company, Bosch boxed. Told me it absolutely could not be the sensor. I looked at the data, absolutely the sensors are bad. He says it absolutely can't be. I've had 2 sensors, they're both brand new. I looked out, he's a German guy. He's got another 4.4 over there. I told him, let's take that sensor and put it over. He says, I'm not doing that, it won't do it. I said, I guarantee it's free if I'm wrong. We put that sensor over there, fix the car. Does it matter because it's brand new? Don't ever, ever get caught in that. Data. Follow the data. I don't care how many new pieces you got on the car. I don't care how many used pieces. It's just the data collection. We're making scientific notation. You're all scientists. You're all calibration engineers. Because you are. You just don't realize you are. But we do it every day. Okay, now I told him, you need a new MAF, dude. Because we're done here. We're not putting your used junk on here, and I'm not going to do any more. Get me a new MAF. Wasn't that much. He got a new MAF. I went across the street. There was another salvage yard over there. I did another deal on that for a crank. No start. So basically, I came back over. He had the MAF sensor. Okay, what do you know right now with the VE? It's fixed. Do you see how powerful this VE is? If nothing else, I know it's fixed. So we had 2 bad sensors and we have 1 good one, and we know right away it's fixed. Here's the trims. I just drove the car. I don't clear them. I drive it to make sure that they move the trim in the right directions. Once they move in the right directions, I'll clear the code and give it back to the customer. I try never to clear anything till I know it's fixed. You dump your Mode 6 data. You dump all the data. You dump everything when you clear them, right? I don't want to do that. I want to be sure what I'm doing. I wait until the car's fixed. Now I clear them. Okay. We have 4.7. Do you start to see how that works? It's a little higher than the engine size, isn't it? Now, your trim. So if that was too high, what would your trim be doing? Taking away? The trim is right because I'm reading the right amount of air at idle now. Do you see that? This trick is huge when you're doing this kind of work, to look at this. 2000 BMW 740iL. This is the car. This car is unfixable. This car's been trying to be fixed for over 1 year. This is a year car. This has been to the dealer several times. It's been to 2 of the top German guys in town. This is a German place I'm at. It's all this guy does. How hard is this? We make it hard. I swear we make it hard. You need a little due diligence and you can make this really easy on yourself. You need to start to think it's easier because it really is. I worked on this car for 15 minutes and I know what's wrong with the car. Now there's something wrong with that, right? Okay, we got a DTC that's lean. We have 2 MAF sensors, all the oxygen sensors in the fuel pump, and that's just the parts this shop's put on. There's way more than that. Okay, so we're going to go drive the car. We're going to use this technique. This is a 4.4 motor, right? How many grams at idle should I have? Or greater, right? Is 4 going to cut it? If 4 was right, where would my fuel trims have to be? 0. Where are they? 19 and 17. Do you see that right up here? It's 19. Now, if I've got low air and I've got 19, what do I think right away? I'm trimming for a problem. I'm correcting it. It underread the air. Doesn't that make sense? Sure it does. So now, I go drive the car. When I put it under a load, I want to see the O2s do what? Stay rich. So I put it under a load and the O2s are what? Rich? Do you see the load came up and the O2s are staying rich? Isn't that super important? I kept fuel control. You've got to start to pay attention if you've lost fuel control or you have it. I kept it. Okay, now, I look at my chart. Okay, right here. 21, 22, 22, 21, 20, 23, 21, 20, 22. It's linear. Do you all see that? This is the key. When you look at trims, it's not that they're all red. It's not that it's broken. You've got to look very specifically. From the idle position to light cruise to moderate to wide open, it's what is my trim? 21%. From bottom to the top, it's how much? 21. Did you see how this is different? The other cars that we looked at, they're 19, 18, and they go to 36. It's a curve. Does it convex or does it concave? That is going to make a difference when you look at these trims. I'm going to show you this. This is linear. If I've got 21, 21, 21, do you see through the whole load it's the same? There's only a couple of things that this can be now. Now I've already limited it. Fuel delivery by the wrong injectors in the motor. Because if I change the orifice size, it gave less fuel idle, midway, full load. Injectors are linear. Does that make sense? If I put the wrong fuel pressure regulator in, it will be linear. But it's got to be the wrong regulator for idle and up. Like let's say I've got a 36 to 44 system and I put a 50 to 60 regulator. In other words, I got 50 to 60 and I put a lower one, which would be 36 to 44 and the whole range from idle to wide open. Do you see if I change the whole pressure, that would be linear? The wrong injectors, the wrong regulator. It isn't just the fuel pressure. The fuel pressure didn't just fall away under load. Do you see that? It stayed the same. So what's that mean? Well, that means the injectors, the program in the computer can be bad. The mass air can be wrong, because it can be linear. We're getting about out of problems there. The O2s, if they're crossed, and I'm going to show you one, so we're not going to go there, and it's a really rare problem. I want you to think about just real basics. What can be linear? A program's linear, injectors are linear, fuel pressure's linear, and a mass air is linear. Those are my choices. How hard is this car? This is a year, guys. I've been trying to fix this car for a year. Okay, what don't I know right now? The air. What's the air? Okay, let's look at it. 21, 22, 21, 21, 22. Does the air match the fuel? It does. The fuel trims are adding 21%, and the difference between moderate and wide open on the mass air is 21% difference. Does everybody see that? So if you were looking at this chart up in here, through in here, I have 21 difference. This chart is the difference between actual air, or reported air from the mass air, and theoretical air. Do you see I have 21, 22, 21, 21, 22? Do you see how that matches the trim? 21, 22, 22, 21, 23, 23, 21, 20. Do you see how they're the same? What side of the problem is this? Is it an injector problem? If it was an injector problem, the VE would be right. If the injectors were wrong, or the fuel pressure was wrong, the VE would read right, and what would the fuel trims be? Skewed. Are they? No, they match each other. The mass air of the program in the car is bad. Do you see how easy this is? All you got to do is think about it and pay attention to detail. Because it's all red doesn't mean anything. You got to really look at how those numbers are plotted on the chart, because it tells you what's wrong. Okay, so now I've got this. I know what's wrong. It's in the mass air now. Yes, sir?
If you had a vacuum leak?
If you had a vacuum leak, we will cover vacuum leaks shortly. If you give me just a second, we'll answer that. But a vacuum leak, where's the vacuum leak? Is it a true vacuum leak between the throttle blade, behind, where a vacuum would be? You will have heavy trims at idle and nothing above idle. But we're going to cover it. Please let me answer that question in a moment. I'll answer it much better, and we will get to those case studies. So right here, what do we got? What do we know is wrong? Mass sensor, or the program. It's one of the two, right? Okay, what do we got to do to the mass sensor? Check the powers and grounds. Check the powers and grounds. What do I do whenever I find anything with a scan tool? Never, ever, ever believe a scan tool. Ever. Prove it. Circuit integrity. Get the idea with the scan tool, scope it. You heard Mr. Colonna over and over. Did you hear him tell you test it with a meter? I didn't. I heard an expert tell you it's a scope. And I assure you that that is the only way you will see some of the problems. You scope it. So what were we going to do? Well, we're going to scope it. Here we go. We've got a mass air sensor. We're in the wires. Do I care what wire? Powers, grounds, and I got a signal. So I got a signal. Okay, I'm going to do my trick. I'm going to snap the throttle, and I came up. And wow, man, it's 4 volts. I'm no BMW guy. I can tell you what the voltages are on all kinds of MAF sensors because I snap a lot of them and I look at them. So I got ideas more or less what it's going to be. I really don't know what this should be. Does that stop me? I'm at a German shop. He's got another 4x4 right over there, doesn't he? One day I said, give me the keys to that car, Roger. So Roger gives me the keys. So I go snap that one. Wow, that's a known good one. Do you see how it's 4.7? Dude, this snap stuff works better than I can tell you. It's a really good trick. So here's what I had, 4.12, and here's what I got, 4.71. Now we already saw though, a couple of millivolts make grams, right? So this is a lot. I've got a problem here. Where's the problem? Is the problem in the program or the problem in the mass airflow sensor? The mass airflow sensor produces a voltage that's looked up in a transfer function table. If the voltage is wrong in the mass sensor, who's wrong? Mass sensor. It is not the program. This is a mass sensor problem, right? Now, I want to go back and I want to show you something. Do you see how this is a metal piece and it's welded in? That isn't what came in that car, is it? Isn't a plastic housing what you use? They use plastic so the heat doesn't transfer as high into the mass air sensor. That's why these use plastic. That's why manufacturers use plastic. It's less thermal energy that can go across it. So most people don't use metal. They use plastic to try to control the heat, because what am I reading with this sensor? Heat. This sensor right here is a stock Bosch sensor. The only thing that changed is the housing. So that isn't what it is. And a lot of these might have some hash, because as you rev the motor, each pull of air is shown here. These are actual pulls of air. As one cylinder pulls in, because I'm wide open throttle, I no longer have a restriction. Every time that the piston goes down, a full load of air goes by, which means I have more air in contact with the wire, which means I have more conduction happening, right? I'm giving up energy into the air. That's what convection is, right? So convection. Okay, so I got a problem. Who's wrong? The mass air. Now, this is the ticket. If you don't get anything out of this class, pay attention right here, because this will kick your teeth down your throat, and I mean repeatedly. This bore diameter. Do you see that mass sensor that goes down into this bore? Have you ever looked at a Ford? Ford uses the exact same mass air sensor on a 4, 6, and an 8. How do they do that? How's the mass the same? When we show you these diagrams of these mass sensors, oh, this is a Wheatstone bridge. Have you ever looked inside that? Is it all that's there? These are very complicated sensors. They are manufactured to have more change under lighter to moderate load than at wide open throttle. There is some significant engineering in each one of these components. This is not a cheap thing for these manufacturers to make. I can't afford to make one of these for every size engine. Does that make sense? How would I do it? How do I make the same sensor work in a 4-cylinder as I make work in a 10-cylinder? Or an 8-cylinder, or a 6-cylinder. You change the bore diameter. That's all you got to do. I use the exact same sensor, and I put a smaller bore on it to where I control the velocity of air. So if I have a 4-cylinder engine, don't I have less pull, so I have less velocity? If I have an 8-cylinder engine, more air is going through, so I open up the bore. All I'm going to do is I'm going to engineer the velocity of the air moving through it is the same on a 4-cylinder, a 6, an 8, or a 10. And I can use the exact same sensor. That saves me a lot of money as a manufacturer. And this is what this is all about, is money. If I change the bore diameter and I make it bigger, what happens to the velocity? It goes down. Would it be linear? Sure it would. Idle, mid, and high. It affects the whole range of the engine, and it's linear. Does that make sense? What that welded housing is a Dynon kit. So this is a hot rod kit, right? Except there's a problem. Whoever put the Dynon kit on forgot to program the transfer function table. When you change the mass air housing, you've got to change the function, the table that's going to change the voltage to grams per second. Once we changed the program in the computer, now was that what's wrong? No, the housing's what's wrong, but he wants a hot rod, right? He's changing it. And when we change stuff, we've got to modify it. So we changed the program, and now it read right. Why? Because now a voltage that's lower than what it was goes over and checks the air rate, and it's different than the original transfer function. So now I'm dealing with the right air rates by the transfer function table. When you get sensors that have tags in them that say they need to be reprogrammed, that's why you're reprogramming it. You're changing the transfer function. If you have a guy who wants to hot rod a sensor and they cut part of the sensor out because it's going to flow more air, the sensor's junk, or you got to change the sensor, or you change the program. Now you can go in and you can extract the program and you can change and modify the function, the transfer function table, and you can make that table work with whatever sensor you did, but make sure of one thing that you understand. The manufacturer has gone to a huge expense to calibrate that sensor and to know the exact voltage makes that much air. When we start messing with it, we can get it back and we can get it to work close, which is good, but you're not going to get it back to where the original factory did. The other things that I want to mention right now, hot rod stuff. Pipes that come into the mass air that are smaller than the mass air, the velocity of the air going through the induction pipe is increased, so when it pops into the housing, what happens to a river? You watch a river where it's going really fast and then it gets wide, doesn't eddies set up? You get eddies. If you look at the original piping on any car that's manufactured, the pipe going into the mass sensor is a larger diameter than the mass sensor itself. That way, when it hits the mass, the velocity is increased and they can control the velocity. If the pipe is smaller going in, you can't control the velocity once it gets into the meter and you'll get unwanted readings from it, right? The other thing that I can tell you is make sure that any hot rod or these air filter kits that you get, you know how right in front of the mass air they take bends? That bend has to be double the diameter of the housing away before it can be bent. If you have a bend that's too close to the mass air sensor, you will misread the air because the air will stay on the outside. Clocking of these sensors. If you notice, when you put these on, they clock. There's rubber notches that won't let you move the sensor. Be really, really careful that you clock them right. That housing in that position of that sensor is put there to read in that position, not over here. If you move the sensor where the sensor sits in the midstream, we'll change your reading from the sensor and you'll have a calibration issue. Always have them clocked right. Never have a bend. You want the furthest, as far as you can get from the sensor, so it's straight airflow, so it has time to get the turbulence out of it before it hits the sensor. If any of these sensor screens are ripped, damaged, or missing, the sensor's junk. It needs a new one. Or it needs a new straightener. That screen that's on there is to promote laminar airflow, so it straightens it. Yes, sir. His point is a very good point. In these aftermarket type air filters, you can move the filter where it does get additional. Let's go one step further. I've seen air filter housings, original ones that are cracked. When the fan turns on, it forces air through the crack and it disrupts the airflow and gives you crazy things happen when the fans turn on. So let's take that one step further than just an aftermarket system. This can actually happen on a factory engineered system that has cracks in it. Okay, now do you see that we reprogrammed it and the VE is right? Did we fix the car? You know we did. Yes, sir. Yes. So basically when you put a Dynon air cleaner and hot rod pipe on here, when you put it on, you got to change the program in the computer so it will recognize that the voltage isn't what is made to be. This car is strictly the bore diameter was increased so more air could go into the motor so it makes more horsepower. Period. The other one I discussed is one I had just done where the mass sensors, two perfectly good masses, and they didn't think it could possibly be the mass, but it was. I was trying to stress the point of not trusting a new part fixes cars. Diameter change. You have to reprogram it because the diameter got bigger, so the voltage output from the sensor is lower. So you got to go into the computer and tell it that that lower voltage really equals more air. More air is really going into the motor than what the transfer function is equating. Does that make sense? His question is the pipe a different diameter? The Dynon kit makes the bore bigger so more air can go down through the motor. Does that make sense to everyone? If I make the bore bigger, the velocity of air slows down. If the velocity of air slows down, it's identical to wind chill. If we go out and it's blowing 30 miles an hour, does it take more heat out of your body than if the wind's blowing 5 miles an hour? It's just, that's the best way to think about these sensors. It's just like wind chill. It works off of convection. We have a 2002 Nissan Maxima. This is the car. So basically we have no DTCs, low power. He's put a used MAF sensor that's known to be good. He's replaced the oxygen sensors and he's put a new ECU in the car. This is the car, no codes. What do you know? 2 monitors have it run. It might not have a chance to set a code. If I look at trims, I've got 23, 27, 38. Do you see how it's getting light load, I'm not adding as much, and heavy load, I start to add more. It's a curve, it's not linear, right? In other words, pay attention to the curves. The curve is light trims on the bottom and heavy trims at the top. Okay, here's my VE. Do you see how we're not even close? We're at 94, 89. That's railing the trims. I can't add more trim than that. That's as much as I can add. That's why the car is running poorly. The car has got a low power problem because it's lean. I can't correct the problem because I so misread the air. In other words, this air, the car has got 100 grams coming into it, and the mass air is saying I have 50. It's half of the air. Well, correction factors with fuel trim are limited. We can't just keep adding fuel because if the sensor lied, I might hydro-lock the motor, right? So I'm not going to just keep dumping fuel. I've got to set some rational point as an engineer that I'm not going to trust that I couldn't hydro the motor. So I'm only going to give you so much trim, and that's it. Once we hit that expected value set by an engineer, that's all you get. That's all we get right here. The VE is flat pegging it. So what are we going to need to do? Back probe the mass air. This is his known good when he uses it all the time. Works really good. Notice the yellow paint? That baby's been in a few cars, maybe a few too many now. We snap the throttle. We have 3.05. If we understand anything I've talked about with analog to digital converters and resolution, I always want the highest voltage I can get. Some of these sensors might hit about 3.7, but most sensors are going to go into the 4s, right?
I have another card to compare. What would be the best way to gauge the concept?
He's got an excellent question. My snap test that I'm doing here, his question is if he doesn't have another car, how could you best gauge this? Find another car. I drive all over looking for another car. I mean, I'll go to a bunch of stops, and every stop I'm trying to say, do you got it? Do you know the car? Do you got a customer that's got the car? Because if you don't know, you just don't know the voltage, right? And his question was, with the last case study with the BMW, with the wrong mass air sensor size, we hit into the 4 volts. That's why I didn't know either. At 4 volts, that might be a good reading, or it might not be, right? So I want another car to compare it to. Don't you have other cars every day coming into your shop for oil changes? How long do you think it takes to roll your scope over and plug these wires and get a snap and save it? That's what I've done. I have a lot of saves of these.
When you say another car, you're not doing that car, just another car.
Another engine that's the same and the other car, a Nissan, that has this motor in it, that's about this year. I don't mean I'm going to go look at a BMW when I'm looking at a Nissan. I mean I'm going to look at the same manufacturer with the same engine. And that engine might be carried in another model. In other words, they change, engines can be across models. Mr. Colonna showed you that earlier, where the trannies were in many different types of cars. They weren't even under the same brand, but the engine's the same. You got to have the exact same engine. Does that make sense? We're looking for the same kind of car. And to answer your question, and there's other ways. How else would I do it? VE table, right? And fuel trims. Isn't that? This is my end result. Where was my starting point? I did a VE and I did fuel trim, right? Then I know the mass air is bad, or I believe it's bad. Why am I here? I'm checking powers and grounds, right? And while I'm here, why not check the signal too? And if I don't know the signal's good or bad, I've already equated that this is my problem, so at that point I might make the decision to change the sensor. Yes, sir?
And the last question. For your grams per second on the snap, on a wide open throttle, for example, in second gear, if you were to log the data and say, for example, it was around 0.8 for 0.8 or 80%, if your grams per second were 80% that of what the car's horsepower is, would you say that that's a good way to gauge, or 0.8 for each horsepower that the car has, a good way to gauge?
His question is, if we did a VE test, and we know how much airflow, you could equate the fuel going into the motor, and the fuel is rated in BTUs, British thermal units, that can give me a horsepower rating by air. This tool does it. We give you horsepower ratings on what air rates are and fuel trims. So yes, you could do that. Okay, right now, 3 volts ain't going to cut it. That's too low. But I'm going to tell you that Nissans, they're 4 volts, and if you got a green sticker, it's 4.4 on a snap. So this is one I do a lot of. I'm familiar with these. So I know it's bad. Our powers and grounds are good, aren't they? So if the powers and grounds are good and my snap is bad, who's bad? The mass sensor. How did we get here? Remember how we got here. Fuel trim by VE. Who's bad? The mass sensor's bad, right? We check it. We've got good power, good ground, and the snap's not more than 3. Who's bad? It needs a mass sensor. Here's a new mass sensor, 3.9. Somewhere right around 4 volts. If it's a green sticker, you have to reprogram them, and they're 4.4. It's just an idea. I'm trying to give you ideas to utilize. Remember that. Don't go out of here with exact numbers and exact case studies. Go out of here with ideas to where you can work this stuff, right? That's what we're trying for, is ideas, not exact case studies. The new math. Does the VE read right now? Okay, so if you took your Modus and you took a reading, or whatever scanner you got, an OTC, and you logged the data and you did the math, can't you do this? Absolutely you can. This is just much easier. But you need to do it. However you do it, you just need to do it. Does the fuel trim's fixed? Yeah. So the car's fixed. Do you understand that? Yes, sir.
How do you bring up the red graph on the scope?
How do you do what?
How do you bring up the red graph on the scope?
How do you bring up the right graph on the scope? The VE? That VE isn't from a scope, that's a scan tool. These VE readings, these are scan tools. All this, the fuel trims and the VE, that's scan data coming out of the DLC. The snaps are the scope. So we look at what? Scan data, and then I'm never going to put a part on without checking circuit integrity. That's why we put the scope on. Then we replace the part. Does that make sense to everyone? We're scanning it, we're scoping it, and then we're fixing it. And regardless if we're doing an engine or a tranny or an air conditioning, we do the same techniques. 2005 Subaru Outback. It's got a 3-liter engine in it. DTC, catalyst efficiency, low power. It's had 2 new cats put on it and all the oxygen sensors twice. So here's my cat. Sure enough, catalyst efficiency, so the cat must be bad, because that code says it is. This is where we need to be really careful with codes. Codes are what? He's waving. He's saying I got a problem. Is that my problem? No, it's not. It may be. I don't know. But I know what? He's just saying, look over here. Always take codes and only think of a code as something as a very basic thing. It's an indication I have something wrong, but not that. Here's my fuel trim chart. Should it have gotten 2 cats? I don't think so. We need to fix fuel correction problems before we ever do cats. So for some reason, whoever programmed the computer programmed catalyst efficiency above fuel trims, because there's no fuel trim code there, is there? There's no lean, there's no rich, there's no anything, there's a cat code. You always got to realize that the DTCs that one gets is a product of the programmer and the understanding of that programmer on the car. What we do, we never look at any kind of cat efficiency until we've corrected the fuel controls issues. That means control, that means fuel trims. I have a problem, right? So we're at 40, 32, 31, 28. What's that? It's worse at the bottom and it's getting better as it gets high. Does everyone see that? You got to look at these tables. You got to look at your fuel trims under the dynamic load. This guy is going from 40, 39, 32, 31, 28. Does that make sense? Do you see that? It wasn't low going higher. That's what we're seeing now, right? Now we've got heavy trims at the bottom. As I loaded, it got better. Here's my VE. 33, 23, 16, 14. Isn't the VE following the trims, they're doing the same thing. Do you see this? They mirror. These two pieces of data tell you what's wrong with the car. When you have trims that are going heavy at the bottom and getting better at the top, and the VE does the same thing, you got an air leak between the mass sensor and the throttle body. You have a mass sensor, and he's out away from the motor so he doesn't get contaminated. He's got boots that go up to the throttle body. Somewhere in that ducting, there's an air leak. The reason that that happens is air has weight and it has velocity. And energy is equated by weight times velocity equals energy. That means as I start to speed up and I got more air coming down, I get less leakage wherever this guy's leaking. The air rams its way in, so the trim gets better. Does everyone understand that? Air has weight, and it has inertia. It has energy. As I rev the motor and it starts getting higher and higher, more air comes down through the tube, which means it is read by the mass sensor. As I have less air, I have more air entering by the leak, so the mass air doesn't read it as much. Does that make sense? The two coincide. Trim and the VE ride together. Now when I look at this, my MAF sensor is low at idle. And also, what am I doing? I'm adding trim. I'm going to smoke the car. So when I smoke it, the air box that's on top of the throttle body is pouring smoke out underneath it. So the bottom of the air box is broken. And that didn't break on its own. Somebody had that air box off and they dropped something heavy on it. It cracked in from the bottom. Nothing that JB Weld can't fix. This guy's a used car sales guy. He ain't going to buy no box, guys, I assure you. I do a lot of work for this guy. I epoxied that box up. You know, it was just a crack. Did I fix it? We know we fixed it, right? VE's right. Trims are right. It's an air leak. And it could be like a tube's off of there, or a plug. You know how some of them have plugs in that induction. The idea is you look at the trim and you look at the VE and you can figure out what's wrong. Now we've got the correct. We got a 3 liter, 3.06. Isn't that about right? So we're good. 2005 Kia Optima. So here's my Kia. We got a misfire number 1, O2 not switching, 3 rebuilt MAF sensors, all the O2s and the injectors all were replaced with rebuilt units. Most of the cars, if you've noticed that I go see, they will never call me until they at least have 2 parts on them. I don't see cars that don't have multiple parts. It's a very common occurrence. So I go drive the car. O2 sensor, the activity, we have no activity. That's what it says, right? We got a misfire, okay? So those are just indicators. I'm not saying that's what's wrong. I'm just going to use it as data. So now, how big's my motor? 2.4? I've got 7.03 grams at what RPM? 700? This isn't a 7 liter, guys. Right? I mean, these numbers mean something. Shouldn't I have maybe 3 liters, 2.4? I'll go for 3. But 7 is a huge number. Do we see that? That's too big a number. What am I doing? I'm taking away 17% on long term and 20% short term. 37% I'm taking away from this car. And with that kind of a number at my idle, I'm believing it. So I'm going to look at my O2. It said there was no activity. Do you see how that's 9.4 volts and that's 9 volts? It never went lean. What's lean? Below 0.8. It's got to get back down to be in stoichiometric, right? And lean is below 0.2. So it's rich. It said it was rich with no activity, so it's above 0.8, right? So isn't it rich all the time? Okay, so that's true. It's rich, and it never switches. So again, I think it's the mass air is way overweighting the air. What is this car? A Kia. What am I scared of with Kias? That bottom number. But I've never seen any Kia or Hyundai that gives you this kind of number. Normally, if I have a 2.4 motor, I might get 3 to 3.5 out of them. Maybe 4, but there's no way I'm going to get 7, so I'm pretty sure. If I go drive it, look at this, 40%. Do you see how everything below 40% is 38, 34, and everything above is good? It's because whenever they rebuilt this, they reset the high side of the sensor, and that's it. You got to realize how sensors are rebuilt. So I was involved in the 90s with a company that did some work with these. I was a consultant. What we did is we took an air tube and we put a fan on it. And we took the fan and we split the fan into a Y, and we put a brand new Bosch hot wire on one side and the broken one on the other side, and we put airflow through it. And then we would look at the good reading on the brand new sensor that worked right, and we'd look at the bad reading, and there's a resistor you can get to when you pop the top cover off. It's the overall calibration resistor on that sensor. They have to put that there because once they make the sensor, that's how they calibrate it. They laser etch the sensor. You just break the traces and you solder a resistor in. So what you do is you dial up the fan and you get air moving, and then you keep changing the resistance with a box until that voltage is equal to this. It's referred to as balancing the bridge. So we're balance the bridge. And why we did this with the hot wires is because that 2.7 platinum wire is directly getting hit by debris coming through the engine. If you notice, there's no protection. If you look at any sensor since that one, it's aluminum ceramic material around it. They're always protecting it because that wire started to erode from getting hit by debris, and when it eroded, it changed the resistance, and that drifted the calibration of the sensor. So as long as that wire was what was bad and you balanced the bridge, it was good. But if anything else in the electronics shifted and you balance the bridge, in 2 weeks it's unbalanced again and you get the car back. That's the problem with rebuilding sensors. We then designed a sensor and we were going to make it, but all the plastic injection was so much money we couldn't afford to do it. So we didn't. But the idea is rebuilt stuff, we're trying to balance bridges and you don't know exactly what you're compensating for. You're compensating for something, but you don't know what. So you compensate it out, but you might do it wrong. He's had a bunch of sensors on this car. Do you see how they calibrated the upper side of the sensor and they left the bottom bad? The sensor's bad. That's what's wrong with the car. The mass air is right under full load. Where do we take this check? Above 50% throttle. Where's your trims above 50% throttle? Good? So you would absolutely have the right air rate under high load, right? How do we know this is a low load problem? 7% at idle. Do you start to see how important that number becomes now? So here's my snap and my idle voltage. I got good powers, grounds, and snaps. When I told the guy he needed a sensor and he says it's $700 and he's already put a rebuilt one on, I've got to make sure that the sensor's bad, right? Just a real quick test. You take a gas analyzer, you pull the hose from the PCV or a brake line off of the intake, you put that probe in that hose, and you read your grams per second, or grams, HC, parts per million. So the parts per million, if you're above 7%, you have a leak. So you've got an injector or something leaking in the manifold. These gas analyzers are tremendous for finding leaky injectors or fuel pressure regulators that might give me a lot of fuel under light load and go away under heavy load. Do you understand what I'm doing? Just verifying it. So I'm under 7, so I know I don't have a leak in there. Dude had to spring for a new sensor, and he paid for this. He lost $400 or $500 on this job. That's the problem with using rebuilt stuff. I'm not a fan of the rebuilt market. As Mr. Colonna was saying, some of the aftermarket filters have problems as well. Sometimes the OE stuff is way cheaper in the long run for your shop than trying to save your customer money. It costs you money sometimes saving them. We put the new MAF on there. There's your fuel trims. There's your VE. Did you fix it? We need one more piece of data, 2.5. What is it? 2.4. We know it's fixed, right? They balanced the bridge of the mass air sensor incorrectly. We just got to understand how we do this stuff. 2003 BMW X5. This is a German shop that has the car. DTC misfire, system lean, bank 1, bank 2. They've put a new MAF sensor on for the car. Check engine lamp. We're going to come in and we're going to look at this. Misfire during startup, cylinder 1, cylinder 2. Let's look at one thing I need to show you. Do you see this gauge right here? The gauge is low. You know that if the gauge is low, you cannot set misfire codes. I want everybody to understand that. When you're below 20% of your tank's capacity, no misfire code sets. It's because if you go around a corner, you can aerate it. And if you aerate it, they don't want to set false misfires. Yes, sir?
Just on BMW or on any vehicle?
No, that's pretty much across the board. And I mean, these are rules of thumb. There's always somebody that's going to do something different, pretty much across the board. And next time you got one that's really empty on a tank, you're low, unplug the spark plug wire and see if it'll set a code. I've actually done this on many cars. Most of them will set nothing. Dead holes. And it's because you have enabling criteria and they've locked the misfire counters off. I just want you to understand that. What am I interested in on this car? It's lean. Stay focused. Why am I worried about a misfire? If it's really lean, wouldn't that make a misfire? So let's not chase things. Let's keep focused. What's our attention? We're lean. That's what the problem is. Okay, here's my chart. Do you see how this is all red? Where is it? Below 20% throttle. As I open the throttle up, what happens? We talked about it with the speed density system. The intake manifold pressure goes away. It comes back up closer to atmosphere. I lose the vacuum. Does that make sense? So if I lose the vacuum and I get rid of my problem, where's my problem? In high vacuum area, right? That's idle. That's an air leak. If I do my wide open test, the VE, do you see how the VE actually read correctly? Why does the VE read correctly? Because I checked the VE above 50% throttle. Right? So if I chuck it up here, what do you expect it? I expect the VE to be right. This is a vacuum leak. And where's the vacuum leak? Behind the throttle blade. Because as I open the throttle up, right, as I open the throttle up, the problem went away. Remember the other car where the air leaks between the mass and the throttle body? Heavy trim's getting better. If I've got a vacuum leak where it's behind the throttle blade, heavy trim totally clears out once I open the throttle. Does that make sense? Works really good. So where do I got? I've got a vacuum leak. Shops, they've already done this. 3 times they've smoked it. There's no leak. Does smoke come out all big leaks? Absolutely not. I personally have had several cars that I've smoked, and I get no smoke out the intake, and I take propane and I find the leak. Smoke is a very poor visual aid. Just be really careful with it. You got to understand what you're dealing with. It's a vapor, right? And I believe in smoke on intake leaks. Usually it works really good. I do not believe in smoke for evap testing. You use smoke for evap testing, you're making a major mistake. Smoke will not come out small holes. I know you think it will. I'll prove it won't. You get a 20 thousandths hole and we smoke it, there'll be no smoke out that hole. And that's what sets codes, right? It just doesn't work. And you need to be aware of that. As long as you know you got a small leak, don't go get your smoke machine because you're not going to find the leak, more than likely, right? So use some other type of method. But just understand, smoke is really limited. Now they've smoked it. Now that doesn't tell me anything right now, right? I'm scared to say, but this is a real easy diagnostics. I don't got to get real carried away here. Because this thing has a crankcase breather in the back. Newer BMWs, it's in the valve cover. They use a valve on their PCV. And when the valve rips, it leaks. And when you smoke it, the smoke goes into the crankcase, guys. And you don't see the smoke because it's in the crankcase. It could be in the valve cover, it can be in the back. You've got to understand that on these cars, and different cars have other things than this, fire traps and stuff, you're not going to see the leak. So you just got to know it. How would you know this? Take the oil cap off of the valve cover and put your hand on top of it, and it sucks your hand in there. It's ripped, guys. This isn't a high-tech diagnostics. You got a vacuum leak. If you think one of these valves is bad, Take the cap off the valve cover. You will always have some vacuum on BMWs there, but when it goes and it sucks your hand, it's ripped. Yes, sir. That's an excellent tip. His tip is, rather than putting your hand, because I'm crude, bad test, I was just taught. You take a piece of paper, and you put a piece of paper over the hole, and if it pulls the paper into the hole, it's ripped. If the paper sits on top of the hole, it's not ripped. That's a good tip. Very good. Like that one. And this happens quite a bit. This isn't that uncommon. But it's really uncommon for us. We'll get burned on this because we're not BMW guys, right? Just be aware that this can happen on these cars. 1996 Ford E150. This is a Ford. We're going to look at him. He's lean. New MAF, new O2 sensors. This is the car. We've got lean bank 1, bank 2. I've got I have 5.3 grams. That's too low. If I'm too low right here and I've got 25% trim, what do you think? That's wrong, right? I'm under-reading the air. Do you see how all the trim is down low and once I get up high, I'm good? VE confirms that. Trim's bad, light, load. VE's good. Smoke the engine. When you smoke the engine, this is a common mistake that I see shops make, and I mean a really common mistake. This boot right here has to be plugged. People try to smoke these things and you can't build pressure, so leaks, you don't see them. Plug the intake. This thing doesn't make enough pressure to where you can just let it dump and you're going to get smoke out. Always plug it. Then you can see the guy leaking down there and the boot's ripped, right? And it popped off. So that's my problem. A real simple problem. Real easy to find, right? VE and trim. VE and trim. They work together. The other thing that I wanted to mention that I just remembered, when we're talking about MAF sensors, we talked about the clock position. We talked about them not being too close to the bend. Make positive that you put the MAF sensor in the right direction. I've been to at least 4 shops. The MAF sensor is turned around. Which way faces the air filter? The screen, the laminar screen. That Kia that I showed you where the mask was there, I did another one 2 days later and the guy had put the mask sensor in backwards. And if you put the mask sensor in backwards, after I saw that, I started playing. So I went out and when I'd do a car and I was done, I would switch if I could switch them, I switched them. Some cars makes it run leaner and some makes it run richer, but none of them read the air right. But I guarantee you can get cars that other people have put the mask sensor in wrong. Look at it. How do you know? The screen faces what? The air filter. Always. Because you're trying to straighten the air before it goes through the sensor to go into the motor, right? If the screen faces the intake, it is in backwards. Put it in right and you'll be amazed at how good it works. And the worst thing of the shop, I'm telling you, that guy pulled that sensor that somebody else had put in there. He put a new one in and he put it in the exact same way as it came out. And that's what a lot of us might do because we just don't know. It's something that happens, so I just want to make sure that I mention that. Here's another car that can't be fixed. This guy right here is a Subaru sales place. All he does is sell. This guy is one sharp technician in Albuquerque. This guy is good. Any car he's got is a harder car to fix. So we're going to go look at this car. They sold the car because they couldn't fix it. And it's had some parts. You can look at it and see. It's got low power. Where? Wide open throttle. New MAF sensor, new O2s, new fuel pump. This guy that I'm working on the car did not put any of these parts in. I can tell you those parts are new by looking at them. This is my fuel trim table. 0, 1, minus 15, 25, 38, 38. How do you get minus to plus? Right now I already know what's wrong with the car. I don't even have to do any more testing. But we're going to always test because what? I never ever believe anything other than the data. But I want to explain how you get those trims. Yes, sir. So these trims, I want to explain this. So basically, what do we got to do? What are trims? They're always based from what? Air. We start with the air. So we're going to go do the VE. VE is right on the money, isn't it? So this isn't on the air side? Where's my problem? If it's not on the air, it's in the fuel delivery. If it's not on the air, it's the fuel delivery. The test divides the system for you. So I know this. I know that the mass air read right, that the calibration's right, that I don't have any kind of air leaks. All that's already equated for me. I know right now that I'm adding fuel under light load, and it's 25, 36, 38. Do you see right here it got worse? But man, up here, -8, -2. Why are these good and these are so red? Because the guy didn't drive in this block, and it cannot trim fuel unless you are in the cell. You absolutely have to get this. If you went from where you normally drive and it trims heavy and then you go to these cells and you don't let it run here, you will not have trim in those cells. I drove the car, and when I was driving it, I kept flooring it. All of these were green up here. And I kept loading it, and then look at what I got. I turned them red because I worked it at wide open throttle. You gotta, if all this is green up here, that doesn't mean that your trims are good. Do you understand that? How often does your customer go and operate his car under wide open throttle? Does he keep it in the cell long enough to actually trim those cells? Do you understand? So if you're not sure, all I did was drive it to where I could set a couple of them. Okay, that's about the same as these. So if the problem is from here all the way to the top. And it's not in the air side. It's fuel delivery, right? Okay, so if I was good here and I started to load it and I started to add fuel, right now I know what I'm looking for. Fuel pressure. Fuel pressure is falling off because as I load the car, it requires more fuel, and more fuel does what? The volume can't be kept up. So the volume starts to fall down, which means the pressure falls down. And if the pressure falls down, we have to add more on time to try to make it right, right? Do you understand? We all understand how that base program works now. Yes, sir?
Why did you give us a couple of negative numbers?
I'm going to explain that in a second. And you'll fully understand it when I tell you what's wrong with the car. Okay, very good question. I want to drive the car. I want to throttle the car wide open and let out of it. This has a wide range air fuel sensor. Wide range air fuel sensors work backwards from a normal sensor. When they drop down in voltage, they're rich. When they go up in voltage, they're lean. Let's go over this one more time. Wide range air fuel sensors, which is a 6-wire wide range air fuel sensor made by Bosch, that actually is being caused by the amplifier, the non-inverting and inverting wires are crossed, so it inverts it, and it inverts the voltage. Doesn't matter why, it just matters it's inverted. So when this drops down, I'm rich, and when I go up, I'm lean, right? Do you see how I floored it here and I let off when I floored it? And do you see how as soon as I let off, it went fully lean in a lean cut? This is a lean cut. I was wide open, dropped the throttle all the way out. When I dropped the throttle all the way out, I went into a lean cut, fully lean, and then I came back and we started to have fuel control. I drove the car and I nailed the throttle right here. Do you see the vacuum map sensor? Went all the way up to atmosphere, which is 83 kPa for me. I'm a mile high. Now notice this whole time this is under load between these two lines. Do you see when I first nailed it, it went lean and then it went rich, and right here it went totally lean before I let out of it? Do you see all this is lean before I let out of it? It cannot maintain fuel control. And this is a different kind of a sensor, so you need to understand. We always see if we can maintain fuel control when I'm on a test drive. I always need to know, did I fuel the engine correctly or not? In this case, it could not overcome with trim. I'm going to put a fuel pressure sensor under the hood. I'm going to read it with a scope. I'm going to go drive the car. Under full load, do you see I'm dropping to 14 psi? So here I'm at 34 psi, I load it, And do you see how it started to go up to 42, and then it couldn't maintain, and it fell? The more I kept it under load, the further it dropped. It's trying to maintain, isn't it? To see it going up and down? But it can't in the end. I can't overcome. The volume is low. The volume being low can't maintain pressure. Whenever you think about pressure, don't think about the pressure. It's always about the volume. The pressure is a result of the volume. Always think about pressure as volume. Yes? No. Wide range sensors, are they always 6-wire? Bosch uses a 6-wire sensor. Nipodinzo uses a 4-wire sensor. So I have different flavors, different brands, and they work very differently between the two sensors. But one thing that you can be sure of is they have more bass. Now the first 4-wire zirconium oxide sensors that you see on all the cars, when you read the white papers, they call it a wide range air fuel sensor. Because 1 and 2 and 3-wire sensors were only accurate right at Stoke. They're accurate from 14 to 1 to 15 to 1. They have no range. When they built the 4-wire sensor, they changed the construction of the sensor. They call it a wide range air sensor in all the papers. And they're referring to going from 11 to 1 to 17 to 1, and I'm accurate across that range. That's all we run cars in, right? So if I take a wide range sensor, I can go up to 24 to 1, but we don't run cars at 24 to 1 because the NOx is so bad, right? And when we do start to run cars leaner, these are good questions because it always makes me think. When we start to run cars leaner in full stratification, that's in a DI, a direct injected car, we do an homogeneous charge when we port inject it. We inject the charge in and it's homogeneous, it's totally mixed. We want it as mixed as we can. It's not totally homogeneous, but we're trying for an homogeneous charge. When we deal with DI systems, it's called stratified or layering the fuel. I layer the fuel layer by layer. It's not fully homogenized. It's contained in the combustion chamber, which is in the piston, right? No car in North America right now runs full stratification because of the NOx concentration. What you're going to start to see is selective catalyst reduction on these cars so we can run them way out lean. And that is going to be created by the same systems you see on like Blue Tech diesels, which uses a urea. Urea is fertilizer. And they call that low emission diesel fluid, right? The low-emission diesel fluid is really fertilizer. Urea is hydraulically cracked in a cap. So when I put in urea, it goes into the presence of moisture, because what do we change the gas to? Didn't we say we made moisture with it? Water? Water is in there. When I have water and urea in the cat, it hydraulically cracks it and it turns it into ammonia. And the ammonia washes the cat out. You run 1 to 1%. So for every 1 part of NOx you're trying to clean, you run 1 part of urea. And it's just a chemical reaction that's going to occur. You'll have 2 sensors in front of these. These are not oxygen sensors. They actually measure NOx before and after. If you have 2 sensors in front, one of them is for ammonia. On the new cars, you'll see 2 sensors in front of it. One reads ammonia and one reads NOx. The ammonia, if you have extra ammonia in there, it creates a drift for the rear sensor. Just trying to give you an idea of what's coming, because that's coming and you're going to see that. So it's called selective catalyst reduction. You can also do a selective catalyst reduction on a gasoline motor by driving it rich, and when it's really rich you can clear out the NOx. In a diesel you can't do it because you can't drive a diesel lean, so they put diesel fuel into the exhaust to make it rich. They directly inject it. And you'll also see that on some of the Volkswagens and Mercedes are doing that. So we have different systems, but be aware that selective catalyst reduction is something you're going to see in your shop, and it's something you at least need to know something about. In this case, let's get back to this case study. I'm losing fuel pressure. They put a pump on. I don't know about new pumps. I don't know about anything. I know about collecting data. What I'm going to do, under the rear seat on the passenger side, the fuel pump comes in through the floorboard. I'm going to pull the panel up. I can see this black-yellow wire. I put an amp clamp on the pump wire. I'm going to go drive the car. Now I have the fuel pressure on my scope and I have the amp reading on my scope at the same time, so I can mark when everything happens, right? So what I'm going to do is, this is the amp reading of the fuel. The fuel pump is at 36 psi. Do you see that? What I want to do is, most all of the fuel pumps that I've seen have 8 commutator bars. A commutator bar is something that keeps the electricity going in one direction so it doesn't reverse from a motor. Motors want to reverse it. If I put a commutator bar up on there, as I roll across the two, I put current through and then it falls off and I cut the bottoms of the negative going voltage away and I get on the next commutator bar. It's how motors work, right? So these commutator bars on fuel pumps on cars, there's 8 bars. So I go 9 positions, or I look for a signature hump. I can also do that. I've got 1, 2, 3, 4, 5, 6, 7, 8. I got to go one more 9 to get back to where I started, because there's 8 bars, right? 1, 2, 3, 4, 5, 6, 7, 8. I go 9, so I'm back. I put a cursor through each mark. Look at your hertz. Do you see how I have 93 hertz? Multiply, that's how many times it cycled in 1 second. Do you understand that? Hertz is cycles per second. If I take the fuel pump RPM, 93 times 60, 60 seconds, right, in a minute? I have 5,580 RPMs. On fuel pumps, the RPM is the biggest thing. It's the key to figure out the fuel pump. The current will follow the RPM. So basically, if I've got 55, I'm looking for 5,000 to 6,000 RPM. Most pumps will turn between 5,000 and 6,000 RPM. So I want to see that. I want to see it hit the target, and I also want to see the overall current about right. This is 4 amps. I'm working with a 36-pound system. 4 to 6 amps is normal unless you're GM. GM will pull more current, that's why they burn their pumps out. Most everybody else will draw about 4 to 6 amps. So I'm roughly there. I've got the speed and the currents about right? And we've got pressure, and it's the right pressure right now. Now, I want to go and I want to drive the car under wide open throttle, and you can see the marker I put down through here. That marker goes up to where I lost my fuel pressure, right? Got no pressure here. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9. I got 96 hertz. I'm turning 5,700 RPM. Now, why this is so important? If the pump lost pressure, it's no longer under a load, is it? The pump starts to spin faster. The faster the pump spins, the less current I get. It goes down. Current goes down the faster the pump spins. It's counter-electromotive force. If anybody's interested, I'll explain it after this, and I'll give you an explanation in detail. Right now, we just need to get through it. The idea is the faster the pump goes, the current does what? Goes down. If I was only pushing 14 psi from 36, the pump had to go free. It has to spin free, which means it should be spinning at 8,000 RPMs is what I did, 8,000. It should go from 5 to 8,000. That tells me that I lost fuel pressure. Like maybe I suck stuff up onto the screen and the fuel can't get into the pump, so I can't make pressure. We know that pressure is equal to what? Volume. Volume. Always think about pressure is volume. So we can't maintain the volume, so what happens to the pressure? It falls away. If the screen got plugged and I can't supply the volume, doesn't my pressure fall away? Absolutely. But what would that happen if the screen plugged? My RPM of the pump has to go up 7,000, 8,000 RPM. It didn't. Neither did the current. If you notice, the current of the pump stayed at about 4 amps, and I didn't speed up. I sped up 100 RPM or something. That isn't enough. It's got to go a couple of thousand higher to get that kind of, I released the load off of the pump. Now, if I didn't release the load off of the pump and the load is still there, you have a restriction in your line. I want to make sure you understand this because it may not be so obvious. If the pump loses its volume, it can no longer push against something, right? If it's not pushing against anything, doesn't it speed up? When you crank a car over and you take the spark plugs all out, doesn't it go whee, and it goes really fast, and when the spark plugs are in there, it's loaded? Same thing, it's an electric motor. If I take the load off, the load being the compression pressure I'm pressing into the combustion chamber is putting the load against the starter. Does that make sense? If I don't have the load, doesn't it spin faster and doesn't the current come down? All motors work like this. If that lost the pressure and the pump really ran out of fuel, it has to spin faster and the current has to come down. That didn't happen. The line is restricted. So something in the line is restricted. Okay, so now I get under the car because I'm right back by the seat, and I'm looking. Well, this guy thought he had a WRX and he was out road rallying, WRC style. He hit a big rock, dude, and it crunched that line. The line is crunched. So now the pump is pushing against the crunch, and as long as the volume is low, between the restriction and the engine, I maintain pressure. When I start needing more volume from the motor, I can't make the volume because the volume is being restricted by the crushed line. But it doesn't have to be a crushed line. Something could be in there like a piece of rubber, because I've seen that happen too, where rubber's in there, right? You know you got a restriction, and you know what points it's between. This is just like a voltage drop test for you guys that understand voltage drops. It's a flow that's happening. So this is a really good lesson. It was real easy to fix this car, right? So they've been working on that car so long they sold it. I mean, we're talking about, I worked on this car for 20 minutes and I know what's wrong. You guys would work on this car for 20 minutes if you use these techniques. You got to use your head. 1999 Chevy Suburban. This is the guy, hard start, DTC, and the hard start, something I noticed. It wasn't what the shop told me. They're telling me they got a rich DTC, low fuel mileage. I have no codes, but they said that this car has been back. They sent it out, no codes, it came back. So here we've got the exhaust. We're not going to worry about that stuff right now. We're going to come over here. I want to look at my trims. Do you notice that down at idle, I've got decent trims, but right off of idle, I have heavy takeaways, 14, 18, 23, 20, but it's not at idle. This is a leaking injector. When you see this waveform, it's a leaking injector. And I failed to tell you something because I start to get hurried because I'm told I got 5 minutes, so I'm trying to hurry here. The last car, I did not answer this gentleman's question. Why are they negative numbers in front? Remember how we were good, and then we were minus 14, and then we went heavy red? Because that's right in the area where the restriction and the fuel pressure is dropping off and coming back. Right at that load, the pressure drops away, so I add a bunch of trim, right? And then the pressure comes back in because I changed the load on the motor right in those cells. And then I got to take away all the fuel. That's why it's taking away the fuel there, because that's right at the point where the volume and the pressure are affecting each other. When you see that, and I've seen this on like 5 or 6 cars, every one of them has a restriction in the fuel system. When you see those minus numbers right in front, they're good in front of it, minus numbers and heavy trims. Every one I've had has been a restriction in the fuel line, one of which had a piece of rubber in the fuel line. That's why I told you you need to be thinking about the rubber. Somebody had crunched, you know how you can push the lines on and you can shave the inside of the line and it goes down in the line? It flipped over and that's your restriction. Just be really careful. We're going to get back to this car. I'm sorry I didn't answer that question, but I want to make sure I'm thorough. So right here, do you see how I'm minus 11, 12, 24, 14, 18? Now this is all good, but why would you know that's good? Because basically these aren't that bad, and these are still taken away quite a ways, but we didn't load the chart over here. I was in a hurry this day. I was over here doing one car, and he showed me this car, and he wanted me to do a second car, and I was pressed for time. Sort of like right now. Still back on that car, pressing for time. VE's right. Fuel trims, everybody here, I've got O2, I'm cycling. We're going to go here. Grams per second is about right. Fuel is about right. Trims, at idle. So now I'm going to come back. I'm what I want to do. When I think an injector is plugging or a fuel regulator, bypass it. Make the fuel pressure present with the key off. I do not want the engine running. I want the fuel pump running where I'm generating pressure in the line. I'm going to take the PCV valve or a brake hose. Make sure the brake hose doesn't have a valve in it, right? It can't have a one. I don't want any valve in there. I want a hose directly into that intake. When I do, I'm going to take the PCV out. I'm going to put the gas analyzer into that line. So now the fuel that's been dripping inside that manifold, isn't that hydrocarbons? So if the engine's hot, doesn't it vaporize and it's hanging in there? So when I suck it out through my machine, I get a bunch of hydrocarbons. If I have less than what it's not leaking, 700 parts per million, there's no leak. Do you think 8,000 is a problem? It's leaking, right? So the fuel leak is in the manifold. The manifold plenum needs to be removed. So I popped the manifold off this car. I bypassed it. I made it have pressure so I can get the injectors to leak. You put this probe down in each hole as you move through them. The injector is not leaking in that hole. The injector is leaking in that hole. Those are the injectors. Notice bank 2 has 2 leaking and bank 1 has 1. And I'm sorry I'm really rushed here to try to get through this, but I want to get a couple of points out to you guys. So right here, do you see how both banks are doing the same thing? You would normally think that that can't be injectors, right? Because the injector would affect one bank. That's not true. That's what I'm trying to show you. Be careful with assumptions. Test. Always test. Don't make assumptions. When you make assumptions, you're usually sorry for them. Okay, so here's one we're going to do, and this will be the last one that I'm able to do. 2004 Mercury, 4.6 liter engine, DTC misfire, DTC low MAF, ignition coil circuits, new MAF sensor, new O2 sensors are installed. This is the car. Notice these ignition coils, A, primary. Are we worried about all this? You know what I think? Who's been unplugging it? I go to shops, right? I'm not believing any of that. Why am I here? Stay focused, guys. Most shops would fix the cars that I go fix for them, but they're not focused, and they get so focused on a DTC they'll never fix it. It says cylinder 5's misfiring, so I've got to do everything to that cylinder when it's another one that's misfiring. The computer miscoded it. You've got to be very aware that computers can generate the wrong cylinder. It'll tell you cylinder 3's missing and another cylinder's missing. It's not even that one. If you'd have done everything to 3 to 5, you'd have fixed it. So be aware that you can have codes that aren't correct. I'm not worried about that. Let's look at data. Here's my trims. One bank, 14, 20, 17, 18, 19, 23, 23. Here's my other bank. -5, -9, -8, -12. I'm taking away on one bank and I'm adding on another bank. When you have a problem that's like this, you have a plug cat. When your O2s are railed and they're all the way out, they're 20+% on both sides, the O2s are crossed. Just want to make sure you understand that. How do I check an O2 problem? I take a voltage signal, a generator. You know, we have one built in our scope, so it's part of my scope platform, but you guys got one maybe that's an OTC one, right? That you can push a button and it makes voltage go out? If you think they're crossed, go down and back probe into the bank 1 sensor. You know, you got 2 white wires, a black wire, a gray wire, and that's on most cars. That's not all of them. That's general colors. 2 white wires, they're heaters. Black wire is your signal, and the gray is a redundant ground. So I want to get in the black wire, right? Put the voltage, key off, scan key on, engine off, scan tool on, hit the voltage, and see which PID, bank 1 or bank 2, comes up high. You understand what we just did? Super easy. This is super easy to fix because sometimes it's not so easy to see them. I just had a Ford Mustang that crossed them on, dude, and you could barely get to the connectors down there, and the engine's hot, and they're down by the bell housing all wadded. And you know, that's so wadded, I mean, I don't want to unwad them and look at wires. So I looked at the other side of the wire, The black one's my signal wire. I'm a flat rate guy, guys. I got to be quick. I got to make money. I get into the black wire on this car. I get my generator. I put it in and I watch my scan tool. I'm on bank 1. Bank 2 came high. They're crossed. Do you understand what I just told you how to do? It does not have anything to do with this car. I'm telling you an idea for another job, right? Don't want to get you guys confused, but I want to get you the data that you need. So if these guys are railed, this one's minus 20s and this one's plus 20s, what do I think first? O2s are crossed. How do I prove the O2s are crossed? I get in one of the O2s with a scan tool, I put voltage on it, and I watch which one the scan tool says it is. If I'm in bank 1 and I give a voltage and bank 2 comes high, they're crossed. Now unwad your mess and plug them in and you fix the car. Does that make sense? There's another case study that we skipped over. Look at it. It's a Volkswagen, it's an Audi, and they cross the O2 sensors. But please, later tonight or tomorrow, just look at it, and it will refresh you on some of this. This guy, I think right now I've got a plugged cat. Why am I adding on this bank and taking away? Which side's plugged? Anybody, which side's plugged? The green side is the one that's plugged. That is absolutely correct. Why? Why does it do this? The reason is, I take the overall mass air going into the intake. We talked about that, right? The overall grams. What do I do with those grams? I divide them out evenly among how many cylinders could have an intake pull, don't I? I feed forward. The feed forward says that obviously all those cylinders took the same air in, didn't they? So if I gave the same cylinder, the same fuel, this guy didn't have any air going in because he's restricted. Are you following that? This guy had more air flowing through him because this guy's plugged. All the air went through bank 1. The air's not going through bank 2. It's always divided equally in the equation. But the equation can't account for these kind of problems. So the equation divided it out equally. When I divided it out equally, I gave the same amount of fuel to both banks. If I have less air going through this because I got a partially restricted exhaust and I got more air flowing through here, I have to add fuel to the bank that is not restricted, and I take away fuel from the bank that is restricted. Does everybody got that? Do the VE. Do you see all this turbulence here? Notice how the other waveforms we've got don't have these huge spikes and drops here? We're doing a 120 to 100. Do you see how much grams? That's 20 gram change. You have turbulence. One of your exhaust is plugged. I know it right now. Now I said we could fix a car going around the block, didn't I? I'm not telling you something that cannot be done. What would be the very next test I want to run? The fuel trims tell me the bank is plugged, right? One cat's plugged. The trims, the VE, a cat test, right? Take your scan tool. Bring up the front and rear O2 sensors. The rear O2 cannot follow the front O2. They've got, I don't care if the rear O2 is high or low, it just needs to be steady. What else do I care about the rear O2? That it moves. The rear O2 trims on all cars. I go to shops that have been working on a car for months and the rear O2 is bad. And it's got trim issues. Do they set trim issues for a rear O2? Do they show you trim that the rear O2 accomplishes? It does not. It looks like the PCM is bad on these cars. That's not what's wrong. When you look at the rear O2, floor the car, get out of it, and floor the car. That's driving it rich. When I floor the car, I punch through the cat. The cat has cerium in it. The cerium is what holds the oxygen bed. That's what I'm storing oxygen in. So when I'm lean, I store the bed, and when I'm rich, I dump the bed, right? So I'm going to punch the car, and when I'm driving it, because I'm on a test drive, right? I've got the rear O2 graphing. I punch it, and I hold it to the floor, and as I go rich, I clear all the oxygen out of the cerium bed because it dumps to make the mixture right? But it can't because there's not enough. I'm giving it more fuel than I have cerium to give up oxygen. So I punch through it. Now the rear O2 at that point has to do what? Go rich. All rear O2s are zirconium dioxide. No one uses a wide range in the rear. They're too expensive. So what does that mean? It goes above what? 0.8. Is that rich or lean? No, that's the amount of oxygen concentration the rear O2 doesn't have with rich or lean because I got a cat in front of it that's further burning the fuel, right? Well, the rich, what we call rich or higher than 0.8, isn't rich on the rear. That means that the O2 can't be compensated. The cat's a piece in between here. Do you understand that? So I want to see it go high voltage. When I back out of it and the cerium bed starts to load itself back up with the oxygen, I want to see the oxygen drop, the rear sensor. You need to make sure, that's all I care about. Once I know that the rear O2 went high and went low, it works. But once I'm looking for a steady state, I pick both O2s, and I'm checking the front and the rear. I'm going to do a catalyst test. I'm going to watch the front and the rear. The front's got to be moving, and the rear is what? I don't care it's high, I don't care it's low, I care that it doesn't follow the front one. Once the rear moves up and down, it works. The rear on all cars trims fuel, and you wait till you get one, and you get bloody from this one. This is one you better pay attention to. The rear O2 can set some really weird trim stuff go off, and you can't figure it out, and you don't think to check the rear one because he doesn't trim. He does. So what do I care? That the rear one goes up and down, and then he's just steady against the front one. That means that the cat has catalyst efficiency. It can work. Does that make sense to everyone? It's working. That's all it means. Now, if I got a plugged cat, the possibility of the cat being plugged would reduce the amount of hits that the hydrocarbons take when they go through the bed. These cats, they have a monolith. In the early days, we had 300 cells per square inch. That gives me a certain amount of surface area. For a reaction to take or occur, the hydrocarbon has to hit a site 4 times. So it means that the gas going out that cat has to come in contact with precious metals. It needs to bounce around, and it needs to hit 4 contact sites to be converted. That means I need a huge area. That's why cats have so much area, is the number of hits it takes to convert it. Does everybody follow me? Okay, new cats have 1,600 cells per square inch, not 300. They're increasing the density so I get more chances for hits and I can convert more. Now, anytime I got a cat, if I've melted it or I've carboned it, don't I start to plug the cat? Okay, now those sites where the exhaust is going through no longer can have the number of hits it needs, so what does it do? It loses the efficiency. Right? So if part of the cat is restricted and I'm checking the front and rear, do you understand that when I'm checking the front and rear, I'm checking the efficiency of that cat? Well, if it's plugged or it's carboned or it has a problem, wouldn't I lose a certain amount of efficiency? So here's a cat test that our scan tool does. Do you see how bank 2, the one we said was plugged, has 62% and the other one has 82%? This one's partially plugged, so I'm not converting the fuel. Since I'm not converting it, the efficiency is low. In order to check this, we're going to take a spark plug out. I don't know how many of you are familiar with transducer testing and spark plug holes. If I take a spark plug out, I can check camshaft timing. Notice what I said? What happens when you're working on a vet that has 4 cams and it's 10 hours to get the cover off? Are you going to guess? You know, these hard cars, I worked on them, and I think the cam's off, and I looked at the front cover, and then I'm going to work on it some more because I'm scared to death to pull the cover. Because what if I'm wrong? If you take a spark plug out and you put a pressure transducer in the hole, you can check to see if your cam timing is right. You can check to see if the spring is broken. You can check to see if the valve is warped and not seating. You can check to see if the seat is beat into the head and it is not seating. You can check exhaust back pressure for a plugged cat. You can check ignition timing. It is a miracle. When I figured this out, I couldn't believe no one else had seen it. Scopes and pressure transducers have been around forever. Can you imagine the gain if you thought your cam was out and you take your scope and you put a pressure transducer in there and you know if the cam is right or wrong and you don't got to pull it down, or you do pull it down? Aren't a lot of you older like I am? I'm showing my age. I used to check a timing light and put it on there and check the timing. It wasn't so I could see the timing was wrong. It was so I could see it was right. If I check camshaft timing and ignition timing through a spark plug hole, it's right. It's sort of like checking the old ignition timing. That's not my problem anymore. Do you understand? In this case, I'm going to pull the spark plug out right here. And all I care is the easiest plug, because I'm looking for a restricted cat on this. If I'm looking for a dead hole or a partially missing hole, I have to be in the cylinder that's creating my miss. Does that make sense? If I'm looking for an exhaust, either bank goes to each cat, right? So whichever spark plug's the easiest one is the one I'm pulling out. So I pull this spark plug out. I screw this in. I put a pressure transducer in. Now, I get this reading and I want to zero in. I want to look at where I snap the throttle. To check back pressure, I need to snap the throttle wide open. Here's the snap. I want to come up and I want to highlight where this is big, where I got the most pressure. I got 190 psi here. So now I'm going to blow this up. This is the piston coming up, compressing the volume in the cylinder. Remember I told you that you worry about volume, not pressure? It's Broyle's law. This guy figured this out in 1600. He made a law that says P and V are equal. They're inversed. So when volume goes up, I get more volume, pressure goes down. When volume goes down, pressure goes up. But what we're really dealing with in pressure is volume changes. I change the volume and I make pressure. In this case, I changed the piston from the bottom of the stroke to the top of the stroke. I changed the volume against closed valves, right? I came back down off of compression. There's no spark plug in here. I took it out, so it can't ignite the fuel. Everyone's got that, right? I compressed it and I decompressed it. When I decompressed it, I opened the valve right here. Now, do you see where I opened the valve and the pressure rose to 20 psi? And we're down here. If I measure from the bottom of the pocket between 30 and 60 degrees after top dead center, that's my exhaust back pressure. So I have 28 pounds of pressure. Do I know that that cat is plugged? Let's look at the other side. Let's say I don't know how to do this. That one doesn't look anything like that one, right? That's because that's not plugged. Do you see when I opened up the valve, I came up maybe 2 or 3 psi? Anything more than 8 psi, you have a partial restriction. By 10 psi, you have a drivability problem you're going to have to fix. 8's a break point. It shouldn't be higher than 8. By 10, you better fix it because you got a problem. By 28, you have a major problem. Does everybody see that? I snap the throttle. Why do I snap the throttle? Because I have a higher volume. The engine can pump more. If I'm going against a plugged cat, what do I want? High volume, so it restricts it and it backs the pressure back up into the chamber. If the pressure goes high at the 360 point, this is top dead center, 180, 360. If the pressure comes way high at 360, it is not a plugged exhaust. It's an exhaust scavenging problem. Camshaft timing, something like that, but it is not a plugged exhaust. A plugged exhaust has an abrupt drive up. Do you see as soon as I open the valve it went up? That's because as soon as you open the valve, the pressure that's pushing against that cat comes back into the cylinder. That's what you're seeing here. So it's a really good test. You can find cats that are partially plugged with this test. With no other way, we'll show it to you. So this is it's really a good test. It's something you guys need to understand. That's a good one. We put a cat on, we fix the problem. Please do me one favor. Go out and try some of this. Don't ever listen to the guy up here. The guy up here's an idiot. Prove this stuff. You got to go out and you got to really try it. You got to see that this stuff can work for you. It will work for you Monday in your bay. And it may not just work immediately. You got to give it some work. But you know, it's like riding a bicycle. Man, I had training wheels on it, and I rode, and I got better, and I took my training wheels off, I fell off, I broke my arm. But I didn't stop trying to ride it, I got back up. Pretty soon I can ride the bicycle all over. But it took a little effort. If you're willing to put a little bit of effort in, your return will be magnificent. You will not believe it. I used to go to work and dread the car that's there. Now I can hardly wait for the hardest car in Albuquerque to go look at, because I'm going to knock the ball over the wall. Just like you guys are going to knock the ball over the wall. Use the techniques. They work. Thank you so much for all of your time. Have a great day.